Hey guys. All right, so here is the practice for exponential functions. I would like to encourage you to pause the video at this point, and maybe copy down all of the tables and graphs and everything nice and neat on your paper, and maybe even attempt them on your own. And then maybe as you're getting stuck or confused, watch up to that point on the video and get help with it, just so that you can challenge yourself and attempt it and see if you understand it. You may surprise yourself, um, but if you don't feel comfortable doing that, then you can just continue watching. All right, so I'm going to go ahead and zoom in on this first one, and then we'll just work from here. All right, so this one is number 1. All right, so here is my function that we're working with. We want to see what it looks like graphically. So how we go from a function to a graph is we have to do a table first, just like in our notes, okay? So here are x values, and we're going to take those x values and we're going to plug them into our function, okay? So this first one I have is 2 raised to the negative 2, which becomes 1 over 2 squared, which is 1/4. So when my x value is negative 2, my y value when I graph it is going to be 1/4. Okay, so on to the next one. Negative 1, so I have 2 to the negative 1, which is just going to be 1 over 2 to the 1, which is just going to be 1/2. So when my x value is negative 1, my y value is going to be 1/2. Moving on to our favorite exponent, 0. We have 2 to the 0, which is always going to equal 1. So when x equals 0, y equals 1. Next, we have to the first power. Whoops. So 2 to the first power, anything to the first power is always itself. Another easy one. So when x equals 1, our y equals 2. And then last, we have 2 to the second power, which we know is 2 times 2, which is 4. Awesome. So when x equals 2, then y equals 4. So let's go ahead and graph that. And let's see if it looks anything like the graphs that we did in our notes. I bet it is. All right, so we have negative 2 to the 1/4. So negative 2, I'm going to say 1/4 is about right here. Negative 1 and 1/2. 0, 1. 1, 2. And 2, 4. All right, so you can see how this graph also has that curve. Okay? I mean, I didn't do perfectly there, but y'all can see what I'm talking about. All right, the y-intercept for this one is right here. All right, so that point is 0, 1. The domain, how far does this graph go from left to right? Well, it looks like it goes on and on forever to the left, on and on forever to the right. So my domain is going to be all real numbers. All right, and once again, this one doesn't go below my x-axis. Okay, it doesn't cover any of these y values here. So it's just going to be all of the positive y values on and on and on forever. So it's anything that's greater than 0 on the y-axis for our range. All right. So once again, you can see that the graph here looks similar. You can see how it's growing exponentially. It's a new nice big word for you. All right, number 2. We have y equals 3 to the x power plus 1, okay? Just that plus 1 on there doesn't change anything. It's just going to add an extra step when we're filling in our table, okay? So we're going to be using this function now, and we want to see what it looks like graphically. But before we can figure out what it looks like graphically, we have to fill in this table. So we have 3 to the negative 2 plus 1. All right, so 3 to the negative 2 is just going to be 1 over 3 squared, which is going to equal 1/9. Okay, then we have to remember to add 1. So that's going to be 1 and 1/9. All right. Now, next we have 3 to the negative 1 plus 1. So 3 to the negative 1 equals 1 over 3 to the first power, which is 1/3. Then we have to add that 1. So that's going to equal 1 and 1/3. Okay. So then we have 3 to the 0 power, which we love because it equals 1. 1 plus 1 equals 2. All right, so right now we have 1 and 1/9, 1 and 1/3, and 2. Next we have 3 to the first power, which is going to be 3 plus 1 equals 4. And last we have 3 to the second power equals 9 plus 1 equals 10. So there are all of my y values. All right, so let's graph this. I'm going to use orange just to keep it the same. All right, so when x equals -2, then our y equals 1 and 1/9. So I'm going to go to -2, we go up to 1, and then 1/9 is just going to be right above it. Then I have -1 and 1/3. So 1/3 of this line is about right there. That feels right. Then we have 0 and 2. So go to 0, or don't go any, and then I go up 2. All right, you can slowly see that gradual kind of arch. All right, so imagine this is like at the very beginning stages of the coronavirus. I know y'all don't want to hear about that anymore, but that is a great example of exponential growth. All right, so then we have 1 and 4. So then we see a little bit of a spike there compared to before. And then we see a really big spike here from 2 all the way to 10. And you can just see how rapidly it grows. All right, and then if the graph continues, it's just going to keep going up, up, and up, and up straight. Okay, so we can see, whoops, that curve. Nailed it. All right, so y-intercept. Here's my y-intercept. That is at 0, 2. All right, then my domain, it goes on and on forever that way. It goes on and on forever that way. So all of my x values that it could be are all real numbers, okay? Then we have our range, which is our y values. Once again, it does not go below this line, but even more than that, our first point was right here, which was 1 and 1/9. So technically our graph doesn't go below this 1. And then it just goes on and on forever above that. So this time it's y is greater than 1. All right, next, number 3. Okay, we have a fraction again. We're not scared of fractions. We can do this. You need to refer back to your notes when we did 1/3 earlier. Okay, this will be the same type of thing. All right, so we have 1/2 raised to an exponent, and that first exponent is going to be -2. So we have 1/2 raised to the -2. Well, we have to remember we have to distribute that to our numerator and our denominator. So that's going to become 2 to this 2 squared over 1 squared, which will be 4 over 1, which equals 4. All right, so when x equals -2, then y equals 4. All right, next we have -1. So we have 1/2 raised to the -1, which is going to cause that to be 2 to the first power over 1 to the first power, which is just going to equal 2. So when x equals -1, y equals 2. 0, our favorite exponent, we have 1/2 to the 0 power, which is going to equal 1. 1 is our second favorite exponent. We have 1/2 to the first power, which we know is going to equal 1/2, because anything to the 1 power is always itself. And then last, we have 1/2 squared. So we need to remember to distribute that 2 to everything. So that's 1 squared over 2 squared, which is going to be 1 over 4. So when x equals 2, y equals 1/4. All right, now let's graph. Okay, so we have x equals -2, y equals 4. So -2, 4. We have -1, 2. We have 0, 1. We have 1 and 1/2. And then we have 1 and 1/4. Or 2 and 1/4, I'm sorry. All right, so once again, we can see the graph is going like that. Dang it. Boom. All right, so let's answer these questions at the bottom. Y-intercept, where is it crossing the y-axis? Right there at 0, 1. Our domain, how far does it go from the left and the right on the x-axis? Once again, it goes on and on forever that way, on and on forever that way. So all real numbers. And then we can see that this one, this time for our y, for our range, the graph never touches this part of my y-axis that I'm circling, okay? But I can see that there are going to be coordinates on this top part of my y-axis, where it's positive. So basically when your y values are greater than 0, which would mean they're positive, is my range. All right. Last one. Okay, just because it has a fraction and this -1 over here does not mean that it's going to be more difficult. Okay, we still got it. All right, so I have 1/3 to the -2 power, and we're going to subtract 1. Okay, so that's 1/3 to the -2. We need to distribute it, so that's going to be 3 squared over 1 squared, which is going to equal 9. And then we have to -1, so that's going to equal 8. All right, so then we have 1/3 to the -1. That's going to equal 3 over 1. Oops. Which is going to be 3 minus 1, which is 2. All right. To the 0 power, we love that. So 1/3 x, or 1/3 to the 0 power is 1. Minus 1 is going to equal 0. Okay, then we have 1/3 to the first power, which is going to equal 1/3. Minus 1 is going to be -2/3. I believe, let me check my notes. Yes. All right, and last we have 1/3 squared, which is going to be 1 squared over 3 squared, which is going to be 1/9. Minus 1 is going to be -8/9. So let's graph it. We have negative 2, 8. 1, 2, 3, 4, 5, 6, 7, 8. We have negative 1, 2. We have 0, 0. We have 1 and negative 2/3. And then we have 2 and negative 8/9, which is going to be about right there. All right, so once again, you can see that the graph forms this curve. All right, so y-intercept crosses through the y-axis right there, which is at 0, 0. The domain of our x values, yep, you guessed it, it's going on and on forever through all of our positive x's. It's going on and on forever through our negative x's. So it's just going to be all real numbers. All right, now, unlike the other ones we've seen, we can see that our graph goes all the way to -1 on our y-axis, I'm sorry, and then it goes on and on forever up. Okay? So, this one is going to be all numbers that are greater than -1. Okay, but not equal to, because we can see that the graph doesn't exactly get all the way onto -1. All right, that is our practice on graphing exponential functions. You can see that they have something in common. Placing it to a real world situation is going to be something like the coronavirus. So when they're talking about flattening the curve, they're talking about flattening that curve of that exponential growth where it spikes up. They want it to start going back down. So it's going to form a curve, and then if it spikes up and then it goes like that, we're eventually going to lower that curve down. So yeah, that's your practice. Day 2, make sure you take a picture of your notes and your practice problems and submit them into Google Classroom. All right, bye guys.